Okay, hello everybody. We're going to find the equation of a plane. So this map has 1, 2, 3 components, but I'm going to just rewrite it as point plus u times a vector plus v times a vector. And so this, you see, is like somewhere in three-dimensional space we have a point, and we're moving either that way or that way, and we get some sort of plane. Now, what's the equation of a plane? So, equation of plane looks like ax plus by plus cz equals d. So, we're going to show a technique to find out what is a, what is b, what is c, and what is d. And this technique will work even in higher degree than linear. So we're going to derive some equations in the parameter variables. In these unknown variables by using the parameters. So what do? We plug in. X is 1 plus u minus v. Y is u plus 2v. And z is minus 1 minus u plus v. And all of this should be d. And so now what we're going to do is we're going to compare coefficients. And this is really important, this concept. So pay attention in the linear case, because it gets a little more difficult when we go to nonlinear equations. But the idea is the same. So first, I just collect what is all the constant terms. Well, there's an a nothing, and a minus c. Now, what are all the terms of this parameter monomial? So then I have a u, or an a, a b, and a minus c. And now what about u to the 0, v to the 1? So where do I get those? I get a minus a, 2b, plus c. And this is equal to d. So what this tells me is that now, comparing coefficients, I see that a minus c must be equal to d. A plus b minus c must be equal to 0 because there is no coefficient of uv, or u, there's no coefficient of u on the right-hand side. And likewise, this must be 0 because there's no coefficient of v on the right-hand side. Compare coefficients in u, v variables on both sides of the equation. Okay, so now I have 3 equations in 4 unknowns. 3 equations in 4 unknowns. What are they? They are the A, B, C, D. That's what we didn't know. So we can write this down. This is a linear system. A minus C equals D. These will be my 3 equations. My first equation here became the first row. Pause and make sure you understood what I did. My second equation here became my second row. Figure out what I did. Third equation became third row. Now I just solved. This is now linear algebra. Linear algebra is the first step towards nonlinear algebra. And so we have to solve. So let's try. So I'm just doing row reduction. If you want, I'm replacing the second row, and I might as well. So I'm just doing this matrix multiplies here and gives me this new matrix. The second row becomes minus the first plus the second. And the third row becomes the first plus the third. y, so I got these zeros. Okay, so now I'm there. So now next, what I'll do is I will eliminate this 2 by taking minus 2 of the second plus the third, and getting okay, so inspecting this equation here, we can immediately read off the solutions, namely that minus 3d equals 0 implies that d equals 0. Okay, great, then the second row says that b plus d equals 0, but we already said that d was 0, so that means that b was 0. And the third row says that a minus c minus d equals 0, but we know that d is 0, so a is equal to minus c. Okay, so there's a whole list of solutions, namely for any value of c, we get a correct solution. And so we could just say, let c be a parameter, and this sends us to a solution minus c 0 c 0 equals a, b, c, d. Now what were a, b, and c, d? They were just, well, for now they were variables, but before they had meaning, they were the coefficients of an equation. And so we see that any equation that reads like minus x plus z equals 0 will work. Or, I mean, literally, what we had was ax plus by plus cz equals d. And what we're saying here is that minus cx plus 0 plus cz equals 0 for any c, for all values of c. And so let c be equal to minus 1. Why minus 1? Well, so that we get x minus z equals 0, which was the solution we got. Oh, we didn't do that before, but well, anyway, this works. Also, minus x plus z works, equals 0. We could take minus 2x plus 2z works, equals 0. All of these are equations, and this is our answer. So let's make sure we answered the question. Prove that this plane is a variety by finding a polynomial equation vanishing on it. Here's the equation, x minus z equals 0.